is our code for PS2 Receiver. First of all, we will use a debouncer to check like the button that the user is press or just release. After that, we use a way to catch the value from the keyboard, since every time when the user click a key on the keyboard, it will send a 3 byte and 11-bit signal. From the first one, 0 is a start bit, and for the last two bits, 9 and 10 is 9 is the parity bit, and the 10 is the slow bit. So these 3 bits we doesn't need it. So we only need the 8-bit beside these 3 bits, which is 1, 2, 3, 4, down to 8. So for this 8-bit, we just store them in our data current. After that, this one is our method to store the current value that the user click the key and the previous key that the user click. So for this one, it just like for the rightmost 7 bits is 8 bits is the current key that the user click. From the left is the most recent previous key that the user click, and just keep shifting to the left, just keep shifting. After that is our is the seven segments displays. So for this one, for the first part is our annual assignment. Since on the FPGA board we have 8 anode to display, so we just assign each anode to each display. For this for the display is just the signal from the PS2 receiver. For the next is our decoder to the key code. Since every key code will send 8-bit hex number, but we doesn't want this hex number to show in the 7-segment display. We want the 7-segment display to show the specific key notes that we designed. For example, if we press Q, the hex value assigned to Q is the 1C, but we doesn't want 1C to be displayed. We want 11 to be displayed, since we assign 11 is the keynote Do. So we just rewrite the hex number that assigned to each key code. So then we can see after that is we just assign it to every 8-bit key code. For this part is just cancel assignment for the each for the which what number we need to for the all number we might be used to display. We will just choose it according to our assignment. Yeah.
This is the melody part. The melody module is the module which generates the sound, and this part for this part it fundamentally receives the keys and produce the different sounds which have different frequencies, which the frequencies are setting through these 2 parts for different sound, like do, re, mi, fa, sol, la, si. And it will basically receive the keys which stored in the register to produce different sounds. And because of this, if the data stored in the register does not change, it will continually to make one unique sound, which means even if we stop playing the Epiano or pressing the keys, it will continually making sounds which linked with the latest key we just pressed. And here comes with the last part of our melody part. And to solve that problem, we add a clock of we add the clock part to count the time. Once the sound is made for 0.2 seconds, the speaker will be turned off, and which perfectly resolved the problem.
Okay, right now is our functionality demo of our e-piano, electrical piano. As you can see, the functionality is really straightforward. When we press the key, Q, it will make a sound, and the display will shows up which key you press. Q, which presents the first line, the first one is 1 1. And when we press the next one, it will shows up the first line, second one is 1 2, and also the next 7 segment display will store the value you just push and the value you last push. When we first running the test, when we push the key on the keyboard, the speaker make a sound continuously. We find out that the speaker make a sound by the value in the register. When we press the key, the value is in the register, but when we release the key, the value is still in the register. How we change this problem? How we solve this problem is we use the changing value to the register instead of the value in the register. So what we can say is when we press the key, it will make a sound, and we hold there. And when we release it, it will make a sound. There's the logic behind the PS2 keyboard and the melody module. Overall, we have totally 21 key, and it can make a 21 different sound. Okay, that is our electrical piano. Thank you.